Sir, it's being live, okay? So we'll start the webinar. Wish you everybody best of luck.
Thank you, sir.
Yeah.
Okay.
Shall we start, sir?
Yes.
Good morning, all. On behalf of Department of Chemical Engineering, KPR Institute of Engineering and Technology, Coimbatore, in association with the Institution of Engineers India, Coimbatore Local Center, it is my pleasure to welcome you all to the IEI Technical Webinar on Circular Economy, Engineering Solutions for Waste Reduction and Reuse Recovery, conducted under the agencies of Chemical Engineering Division Board, IEI. I'm Lieutenant Dr. Priya, Committee Member, IEI Coimbatore Local Center and Professor, Department of Chemical Engineering, KPR Institute of Engineering and Technology, Coimbatore. Now I invite Dr. J. Krishnamurthy, sir, Chairman, the Institution of Engineers India, Coimbatore Local Center, to deliver the welcome address and presidential address. Over to you, sir.
Thank you, madam. A very good morning to all present online, joined in this webinar today. As chairman of the IEI Coimbatore Local Center, I am delighted to deliver the welcome address in this IEI technical webinar on circular economy being conducted under the aegis of Chemical Engineering Division Board of IEI. I would like to extend a heartfelt welcome to our distinguished panelist, Dr. J.S. Sudarshan, Head, School of Engineering and Environment, NIC MAR University, Pune, Dr. S.T. Ramesh, Professor, Department of Civil Engineering, National Institute of Technology, Tiruchirappalli, and Dr. K. Kannan, Principal Scientist and Head, Crop Production Division, ICAR Sugarcane Breeding Institute, Coimbatore, who will be sharing their expertise on circular economy. Additionally, I would like to welcome Dr. G. Madan Mohan, Honorary Secretary of IEI, Coimbatore Local Center, Lieutenant Dr. A.K. Priya, Committee Member, IEI Coimbatore Local Center, and Professor, Department of Chemical Engineering, KPR, Institute of Engineering and Technology, Coimbatore, and Mr. Ayan Deb, from the headquarters technical department, whose contributions are instrumental in organizing this webinar. I would like to express my sincere gratitude to the principal and the management of KPR Institute of Engineering and Technology for their continued support and collaboration with the IEI Coimbatore Local Center in organizing various technical events across different engineering divisions. I am pleased to welcome IEA council members, IEA various committee members, IEA corporate members, faculty, staff, and students from KPR Institute of Engineering and Technology, as well as participants from various sectors across the country. In all our IEA events, it is my duty to talk about IEA and its activities. The Institution of Engineers India is a prestigious professional body with over 2 lakhs engineers from various disciplines as members. Headquartered in Kolkata, IEI has 125 centers across India and 6 overseas. Our Coimbatore local center has been active for the past 60 years. IEI supports for a wide range of technical activities, including guest lectures, workshops, seminars, webinars, exhibitions, and both national and international conferences. It also sponsors students' events such as quiz programs, paper presentations, technical competitions, symposiums, and project exhibitions. Additionally, it provides funding for final year projects of diploma, undergraduate, postgraduate, and PhD scholars. Today's program is one such sponsored event. Engineering advancement in waste management, recycling, and resource recovery are essential to transitioning from a linear to circular economy, which can help mitigate environmental impacts and create economic opportunities. I hope this webinar on circular economy will educate the participants on cutting edge technologies and foster collaboration, driving a shift toward more sustainable production and consumption practices. To all participants, I wish you a rewarding, insightful, and enriching experience during this webinar. On behalf of IEA Coimbatore Local Center, I once again extend my warm welcome to one and all for this webinar. Thank you. Thank you very much.
Thank you, sir. Now I like to brief about the webinar. The IEI technical webinar on circular economy, engineering solution for waste reduction and resource recovery aims to explore the innovative strategies and engineering approaches that contribute to a sustainable and circular economy. In today's world, the linear approach of take, make, dispose is one longer viable. The circular economy offers a transformative shift towards the sustainability by promoting waste reduction, resource recovery, and regeneration of natural systems. This webinar brings together the experts, researchers, and industry professionals to discuss cutting-edge technologies and practical solutions that can turn waste into valuable resources. As the world shifts towards a more sustainable and circular economy, it is crucial to explore advanced bioremediation techniques, biomining solutions, waste-to-energy technologies, and efficient resource management strategies. The key highlights of this webinar is to understand the role of engineering in the circular economy, innovative technology for landfill remediation and biomining, sustainable waste management practice for industries and municipalities. Our distinguished panelist includes Dr. J.S. Sudarshan sir, Dr. S.T. Rameshwar and Dr. K. Kannan sir will share their expertise and insights on how engineering and technology can play a pivotal role in building a sustainable future. Let us make the most of this opportunity to learn, share, and contribute to the journey towards a circular economy. Now, I am happy to introduce the first panelist. It is my privilege to introduce our distinguished panelist for today's webinar, Dr. J. Sudarshan sir, a renowned expert in environmental engineering and sustainability. Dr. Sudarshan is a chartered civil environmental engineering professional with a doctorate in environmental engineering and over 2 decades of experience in teaching, research, and training at prestigious institutions. He is an IGBC accredited professional and has made significant contributions to academia, research, and industry. With over 2 decades of experience at top ranked universities, he has been instrumental in teaching, research, and training in areas such as life cycle assessment, smart water management, waste reduction, net zero strategies, etc. Currently, he serves as the head of the School of Energy and Environment at NICMA University, Pune, where he established India's first MBA program in environmental sustainability and sustainable energy management. Dr. Sudarshan has an impressive research portfolio, having published over 136 Scopus Index papers, 33 SCI Index papers, multiple book chapters, and 2 books on construction management and repair rehabilitation of the structures. His 3 patent publications and ongoing research projects works worth 20 lakhs funded by the NICMA University and ICSSR. Highlights its commitment to innovative solutions in renewable energy, waste management, and sustainability. Additionally, he has worked on government-funded projects supported by BARC, DRST, and QCI, received over 11 prestigious awards, and actively engaged in corporate social responsibility initiatives focusing on water conservation, waste management, and environmental awareness. With his deep expertise and passion for sustainability, today he will share his expertise on circular economy for construction and demolition waste reduction and resource recovery. We are honored to have him with us today. Please join me in welcoming Dr. J.S. Sudarshan sir. Now the session is yours. Please carry on, sir.
Yeah. So, good morning to one and all. So, first of all, it is a great privilege and honor to be a part of this webinar, panelist in this webinar, because this one particular topic, the circular economy, is one of the need of the hour, and even our Prime Minister is insisting on circular economy in all the sector, which needs to be implemented and which needs to be followed in all the sector. So, at this particular juncture, this particular topic and this particular webinar is very much significant at all levels, not only at the research level, in the corporate and industry and all levels, it is important. And also when I talk about the panelists, so they have meticulously identified the panelists for this webinar, because as I am a person from engineering background, but also I am working in the management area, because our institute is one of the renowned institute in construction management in the country, and also we are the only institute exclusively for catering towards the CRIP sector, construction, real estate, and infrastructure and project management sector. And we are the only university in India exclusively for construction, real estate, and infrastructure and project management sector. So in this aspect, I am very much honored and happy to be the panel member. And also the second panel member, who is my friend, who is working in NIT Trichy. And he is also a renowned researcher, and he has done many studies related to the biomimicry and other things. So he will highlight about some of the aspect with respect to the circular economy in waste processing and other things. And the third person is a researcher from a research institute. So what I want to highlight here is three expert members from different sector like management, engineering, and research institute is one of the added value to this webinar, because so that the platform will be a very good discussion will happen and very good outcome can be achieved by means of this panel discussion. So my topic of my presentation is pertaining to the circular economy in construction and waste management. So that is a main aspect I'm going to discuss. And this presentation will continue for another 30 minutes. So I will be highlighting some of our findings, what we have done with respect to the circular economy, with respect to the C&D waste management, because C&D waste is another one important area where huge amount of attention is needed in our country. So that is one of the reason we have taken up this particular topic, and we are doing research in this particular area. Presently, what I am going to present is part of our research, what we have published and what we have done. So thank you very much again to all the organizers. I'll continue my presentation. Yeah. So the outline of my presentation, I'll be discussing about what is meant by circular economy and what is the need of this particular topic, and also the objective of the study, what I am going to take it up. And then I'll be talking about some of the case study with respect to the thing what we are doing with respect to the circular economy, and then how we have procured the data and how we have collected the data, and then what is the difference between linear economy and circular economy. And then I'll be talking about BAMB model and that is material processing, material passport technology. So which is one of the unique things which will help you to do many initiative with respect to the thing. And also I'll be highlighting about our research finding based on this study. So waste management practices, present waste management practices. This is a common waste management practices. Most of the sector adopting and most of the sector it is happening. So we are procuring, we are manufacturing the material, we are developing the material, and then the material is manufactured. And then after manufacturing, the material is used for different activities. And then after the usage, the material is reaching the landfill. So in all the sector, not only in one sector, in all the sector, the process is happening in the form of linear way, not in a circular way. So that linear way process, what is happening due to the technological development and due to the modern materials, what is in practice, which includes many hazardous materials also coming into the picture in this linear economy process, which is creating enormous amount of environmental impact, enormous amount of damage to the system. So that is one of the very important thing which compelled and which forced us to think about some of the alternative, and that alternative is a circular economy, what I am going to highlight. Because in this linear economy process, it not only creates the environmental impact and ecosystem damage, it is also increasing the volume of landfill. So that is another major issue happening in most of the cities and towns. So now the government is taking many initiative to implement the circular economy process in all the sector. So in construction and development, construction and waste management sector, I'm going to highlight the thing how it can be possible. So this is the normal process with respect to the circular economy. So raw material extraction, then design, and then the designing the raw materials as per the way that how it can be again reused and reutilized and refurnished. So in that way, the design needs to be carried out, and then production and remanufacturing, then distribution, consumption and repair and reuse, and then residual waste, and then recycling. So when we talk about this process, this is one of the very important process which needs to be enforced and which needs to be followed in all the sector, which will help to reduce the waste reaching the landfill, and also we can get many products, that is resource recovery also possible by this kind of initiative. So it is very much need of the hour that we have to think about the circular economy instead of depending on the linear economy. So this is the thing how we can adopt and implement with respect to the circular economy. So this is a simple thing. So only thing is, it is necessary that our mindset needs to be changed, or the human mentality needs to be changed. So that is another important thing we have to make ourselves clear. That is how we can design the material, and that material can be having further applications. So management of C&D waste through circular economy. So now I am going to the main picture of our discussion. So the thing is, traditionally the construction industries follows a linear economy, meaning that the materials are extracted, used to make a product, and disposed on the landfill at the end of its life. So several attempts should be made to transform the industry into a linear to circular system, similar to the natural world, that there is no waste. One organism's waste becomes another organism's food because there is no landfill in nature. So as I already pointed out in my previous slide, the main significant advantage and importance of the circular economy is we have to reduce the waste reaching the landfill. So that is one of the very important thing we have to keep in our mind. So keeping this in mind, we have to find a way how that can be possible. So that is why we are trying to enforce the circular economy, and it can be achieved by means of adopting triple R, adopting 5R formula, and all these things are possible to enforce and implement the circular economy in the construction and demolition waste management. So what is the reason why we have to think about it? This is because even in the recent studies also highly pointing out that recycles only 1% of the construction and demolition waste out of the huge amount of waste generation. Maximum waste generation is reaching the landfill. And also another pathetic condition, another pathetic thing is in the towns and semi-urban areas, it is not at all reaching the landfill also. It is just dumped in a barren land, and also it is dumped in the low-lying areas without any proper permission. That is also happening in many of the places. So as it is creating a lot of impact to the groundwater, as it is creating a lot of impact to the environment, it is very important that we have to focus on this area, and we have to find a way how that can be achievable and how that can be possible in the case of implementing the circular economy. So that is one of the main reason we have taken up this particular study. So what are the objectives? The three objectives which I have highlighted here: to compare the C&D waste generation in linear economy and the circular economy, and then promoting the reuse and recycle of existing building material product, how that can be converted into useful product, and establish the material passport platform, which will help the various actors among the construction industry to assess the data, product availability, its quality, and its manufacturer, etc. So the technique what I am going to explain in this particular research study, what we have carried out and what we have produced, which will be taken up further by any researcher and also by any corporate, and they can take up this particular study and they can implement it in a realistic way to achieve this circular economy in the real situation of the waste management, C&D waste management. So that is one particular thing. I hope that is possible by this discussion. It can be achievable. So the C&D waste scenario in India. So this is a thing everybody knows. The study showed that about 90% of the C&D waste can be reused in productive and profitable application. Productive and profitable applications. 90% of the C&D waste can be used in productive and profitable applications. The very important and very significant aspect what we have to kept in our mind is, as I already pointed out in the previous slide, before constructing the building, it is necessary that we have to, during the process of manufacturing the material and during the process of designing of the building itself, we have to think about the circular economy strategies, how that material, how the product can be reused, recycled, and refurnished. So that is one of the important thing we have to kept in our mind. The 3R needs to be kept in our mind during the stage of designing the building and also during the stage of selecting the material for our building construction activities. So that is one particular thing. That is why it was mentioned 90% is approximate. It can be possible. Further, we can, if we implement and if you follow the strategy properly, we can achieve more than 95% of C&D waste can be used. So another important aspect we have to kept in our mind is source segregation. In many of the cases, the source segregation is not happening. So if it is Coimbatore, if it is Tamil Nadu, if it is Pune, if it is Maharashtra, wherever you go, it is necessary that the construction site and the construction project area, the construction and demolition waste, before starting the demolition activity, we have to clearly bifurcate what are the waste can be further reused, what are the waste can be further recycled, what are the waste can be further refurnished. That needs to be categorized. And after categorization of the thing, it is necessary that we have to take up the initiative of demolition. So any of the project, maybe very few project they have initiated, they have carried out all these things, but most of the project happening in the semi-urban and also town and also in some of the city project also, it is not happening in that way. They will randomly demolish the thing and then certain type of product will be used for dumping the low-lying areas. Remaining other product will be sent to the landfill. So that is the thing happening in most of the cases. Even that salvage value is not at all calculated. It is necessary that we have to think about that aspect before start demolishing the building. So then only it is possible we can achieve the circular economy in our realistic way. So that is one thing. That's why I told source segregation is one of the important thing. So here the circular economy, according to the Ellen MacArthur Foundation, is one of the ensures that product, component and materials retain their maximum value and use. If you think about in our day-to-day activities, whether we are utilizing n number of products in our day-to-day activities. If you categorize how many products we are making use of maximum, how many product we are making use of it maximum. Even in our day-to-day activity, the simple example is mobile. If you think about the mobile, what is happening is when the new version is coming out, when the new material or new product is coming out, what we are doing is we are not thinking about what will happen to the old mobile. And in some of the cases, the old mobile is exchanged or old mobile is recycled. That is fine. But in many of the cases, the maximum utilization of the product is not happening. So even the packaging material, when we are ordering something on the online, the different types of packaging materials are used. But whether the packaging material that what is we are disposing of, whether it is properly managed, whether it is properly reused or refurnished, it is not clear. So that is one of the reason it is necessary that we have to think in our mind the circular economy concept. The term circular economy refers to keeping resources in closed loop with waste seen as a valuable output and linked with a process that can give value as an input. The circular economy is built on three basic principles: maintaining and improving and natural capital, increasing resource yields and reducing environmental impact. So it is a very simple and basic mantra which can be adopted, which can be followed. Even in our country, our forefathers followed this circular economy, not in the form of circular economy, but in a different way. So that is a known fact. That is why in our towns, in our cities, there will be a separate street where there will be a salvage vendors will be there. So the salvage vendors will take all the wooden frames and all the wooden. See, nowadays, even this wooden frames also gone. In all our activities, in all our things, because of low cost and other things, we are not using the wooden frames. In many of the cases, we are going for UPVC, SE and other many kind of materials are available in the market. Those materials are used in that case. So it is right. We have to modify. We have to upgrade ourselves. We have to change our system, but we have to ensure that how that UPVC can be refurnished or how it can be again reused when it is dismantled. That needs to be think before adopting and before implementing that particular thing in our activities. So that is one of the important things. That's why the circular economy is gaining more momentum and more significance in the present day market and present day situation. Right. So I am moving to the main thing, that is we are trying to introduce as a new concept in the circular economy. So that is building as a material bank, BAMB. BAMB, building as a material bank, build, use, reclaim, reuse. So what I want to highlight here is I'm trying to integrate the circular economy in this particular concept. So this is a very, it is new to our country, but in many foreign developed countries, especially European countries, they are adopting and they are using this kind of techniques in many of the application. So this kind of techniques can be adopted and implemented in our construction and demolition waste management in the construction industry also, which will help the different stakeholders in construction industry get benefited. Different stakeholders in construction industry can get benefited by this kind of initiative. Buildings as a material bank. Actually, buildings as a material bank, but we are not realizing the value of the material what we are using in the buildings. That is a major problem what is happening that leads to the generation of more amount of waste. We have to think about how that buildings can be converted when it is demolished or when it is dismantled, how that building material can be converted into a bank reserve, which can be used for some other application or some other stakeholder can use that material for different application. That is the logic behind this buildings as a material bank. Right. So how we carried out this initiative? So we want to find out what is the awareness level of the people. So we have identified different stakeholders and we have developed a questionnaire. We have floated a questionnaire among the different stakeholders. And then we have collected the data and then we have analyzed the data. And based on the data analysis, we have different category of the stakeholder we have divided. More than 206 responses we have received based on the survey. And also we have done some expert interview also from the different people who are working in the field of construction sector and CRIP sector. And then we arrived at the outcome. So you can see this is a type of the sampling questionnaire responses what we received from different level of people. So maximum we have received from architect, interior designers, and also the managers, engineers, and supervisors. That is a maximum thing. And then what is the type of material? So you can see here steel component, beam, columns, and girders, roof materials. That is a different salvage material. And there are different type of material can be generated and produced from this kind of salvage material. But in the present day situation, the salvage value itself is not properly calculated and the salvage value of the material is not properly analyzed or properly studied. That is another important thing happening because they want to complete the project faster and they want to achieve the thing within a short period of time. So they never think about all these initiatives and all these things. Automatically, when there is a provision to dispose or dump in the landfill, so why they have to think about it? The government, there are many initiatives. The government is giving incentive. The government is promoting many initiative of recycling and other things, but still the awareness level, among the different stakeholders, the awareness level with respect to the circular economy, with respect to the C&D waste management is very, very, very minimum. In cities, somewhat it is okay, but in towns and semi-urban areas, the awareness level is very, very minimum. So that is one important thing I want to highlight from these findings. So this is the further responses based on the questionnaire. So you can see here awareness of building as a material bank. So the maximum. So here most of the people, they are not at all known about circular economy. Most of the people, they are not at all aware about the building as a material, building material as a material bank. And most of the people, they are not at all aware about the material passport. And some of the people, those who are aware also from the cities and also from research people, the research organization, the postgraduate students, they are only aware about that particular thing. And most of the people, they are not at all having any kind of ideas and clarity with respect to this particular aspect. So that is one important finding I want to present in this forum. Then what is material passport? Material passport is a document containing a detailed inventory of all the material resources and components of the product or building, as well as detailed information about their location, providing material with identity they are independent or of their current use. So you can categorize the material. Again, it is important that before jumping into the action, it is necessary that we have to first identify. Even in my presentation, I'm going to highlight that also, how it is possible. So we have to find a way, what is the type of material, what is the value of the material, how much salvage value it will give, what is the characteristics of the material, from where it is available. Like this, we have to make a categorization of the material and then we have to develop this thing. So you can find out how it can be possible. So this is another important way, building as a material bank. In this vision, the building itself is considered as a materialized savings account. So you have to see the building itself as a savings account. That is why I mentioned as buildings as a material account, material bank. The material resources through which building materials, product and components are temporarily deposited into a functional element are part of the building. By harvesting materials and parts during deconstruction and renovation of the building, these material can be reused in the construction, operation or refurnishment of other buildings, that reducing the need of the primary resource of mining. So automatically now the resource recovery is achieved by means of this. So I'm highlighting in our today's panel discussion, there are important aspect which was highlighted in the topic. One is resource recovery, second is circular economy, and third is waste management. So by this particular initiative, by this particular study, or by this particular method, it is possible, and it was proven in many countries that we can achieve all these three. Circular economy can also be possible, resource recovery also can be possible, and we can also reduce the waste. Waste management can be effectively done. So that is one of the important thing, how the buildings as a material bank. Then this is a small video, so just it will have just 2 seconds video. So
imagine buildings as material banks. Instead of buildings being demolished after use, they're carefully disassembled. Their parts are reused or recycled at the same or even better levels of quality. Instead of the traditional take-make-waste system, this supports a circular economy, where waste no longer exists. Materials passports enable circular business models by defining materials and showing their circular pathways. Suppliers, builders, architects, users, and next users all provide and retrieve information through a digital platform. The goal is to put materials in continuous loops of use and reuse. For instance, the maintenance loop. Materials are maintained properly so their use period is maximized and the value for recovery is ensured. The reprocessing and energy production loop. Biosphere materials can be safely cascaded into new products before they eventually re-enter the biosphere through incineration or composting. The refurbishment loop. Technosphere products can be refurbished by the manufacturer or service partners. The recycling or upcycling loop. Technosphere materials can be recycled into new products while maintaining or improving their quality. Many products are not yet designed for circular use. The Passports platform provides a feedback loop so everyone can optimize their materials, products, design, and services for better circular use. Materials passports, enabling the transition towards a circular economy.
So I have to acknowledge that BAMB group who have developed and who have created many initiatives and many things with respect to this material passport and how that circular economy, how that can be possible in the waste management sector. But it is even many advancement has been done in this area, but still the awareness level with respect to this particular concept in our country is very less, and very few patronage with respect to this particular thing. So it is one of the excellent idea and excellent concept to transform into a business, because it is like a thing how we are purchasing big basket and other things, many product online groceries and other things we are using. In the same way, the building material can be categorized like this, and the building material can be created, a platform can be created, and the platform can be created exclusively for salvage, that is demolished material. But it is necessary that the material what we are demolishing needs to be properly source segregated. That's why I told source segregation is a very, very important thing. We have to do the source segregation before jumping and before making into the action. And then next important thing is we have to identify the characteristics of the material what we are demolishing. So if we don't know the characteristics of the material, then it is not possible to achieve all these things. And we have to combine, we have to form a group so that all the stakeholders can be joined together and that can be achievable and that can be implementable. If the stakeholders are not joined together, then this thing will be only as a research and this can't be taken up or this can't be taken forward and implemented in the reality. So this is a case study what we have taken up. We have taken a demo project for comparing linear and circular economy. So this is a sample and the final area of the building is 69.50 meters squared. So it is a small thing we have taken up for our case study to discuss about how this linear economy and circular economy can be in a reality. Then we have calculated the C&D waste. So this is a calculation was done based on the TIFAC. There is a thumb rule by TIFAC. So we have considered the thumb rule, and based on the thumb rule, we have estimated the quantity of the waste generated and quantity of the waste will be created from this demolition. So we have created this. And then what we have find out is the research was conducted as a study, that is Indian construction industry. And first and the main important outcome is in linear economy, all the waste quantities gets dumped near roadside, riverside or near vacant land. In linear economy, all the waste quantity gets dumped near roadside, riverside or near vacant land. And some of the areas, some of the cities, it is reaching the landfill. It ultimately creates impact in our environment as well as it makes higher raw material usage for making new material. So automatically by this kind of initiative, the linear economy will lead to more environmental damage, more ecosystem damage, and also it will leads to production, that is more mining and also more raw material is required for manufacturing of new material. Therefore, it is high time to think about how that can be changed. So the only way is circular economy and BAMB model. So where it is possible, we can achieve the resource recovery, we can achieve the effective waste management, and also we can convert the product into useful material. So the circular economy, we will not only reduce the amount of C&D waste, and this will also help the target of our countries to achieve the net zero. That is also possible by means of this initiative. And not only that, the emissions drastically will reduce. So these are all several advantages. When we are trying to adapt and we are trying to implement the circular economy, it will lead to several advantages. So this is one of the important things we have to keep in our mind. There are 41 number of single flush doors and 56 number of windows in our case study. This is pertaining to our case study. So we can extract them and can sell them through a material platform website. So I have given here as an example. What I have presented is a example how we have created based on the case study, how we have created the material platform. I am highlighting in this particular presentation, but it can be transformed. It can be converted into a major revenue generation business. It can be made. So for example, before demolition of the structure, we can extract the bricks which are in good shape. That's why I told source segregation, which are in good shape and having adequate strength at the time of the construction. So total number of bricks, how much total number of bricks are used, and out of 13,220 with respect to this case study area, what I have taken, I have presented here. It is possible we can try to get at least 70 to 80% of the material can be used for further application. Then the very important thing is we can sell some of the bricks through our material selling platform website and can earn good amount of money. And then for achieving our third objective, we have created a demo 2-stage website of material selling platform. And then the salvage value can be produced. So you can see here, this is a material selling platform which was created, and this is a screenshot. Like this, there are many development, there are many things can be possible. And then this is another thing which will help to identify and select the material. As I already told in my beginning of my presentation, during the time of the design itself, it is necessary that we have to think about proper design so that maximum material can be reused. That is possible by means of BIM, adopting BIM in the project. So by adopting BIM in the project, you can categorize the material. You can clearly mark the material which will have maximum usage, that is possible. And then we can mark it. We can give of different identification mark or different RFID code or something we can give, so that during the time of demolition, that material properly, it can be demolished and it can be used for different application. So that is why it is not only possible only at the final stage. It is necessary that we can achieve this only by means of starting from day one of our project initiative. Starting from day one of the project, we have to think about it. We have to see how that material passport can be created, how the circular economy can be created. That needs to be planned. And all the stakeholder needs to be joined as a team. Then only it is possible. It can be achievable only by means of integrated way of approach, not by a individual way of approach. The circular economy or this can't be a successful thing. It is necessary that integrated way of approach. Even when we take up this study, we face a lot of difficulty in getting the data. So that is why we have taken some dummy project. We have taken some demo project and we have done the trial, because we try to achieve it in a real live project, but we are unable to get any kind of live project data. So that is a difficulty, limitations what we have faced when we are trying to use this. And also different material, the people, the salvage vendors, they are thinking about maximum value, which material they will get. That only they are looking into it. They are not at all thinking about the material which doesn't have maximum value. That is another issue what we have faced. So you can see here. So this is the way how we can be categorized. So what are the different material, and we can categorize the material and properties. All the things can be achievable. Then once this is done, then automatically it is very easy to implement and follow the circular economy process, starting from initial stage, building construction stage to the demolition stage. It can be easily achievable. So that is why I told adopting of 3R, reduce, reuse and refurnish, is a very easy and simple mantra which can be implemented. This mantra will help to implement circular economy, waste management, effective waste management, and also it also help to achieve the resource recovery. So these are all some of the outcome what we have achieved by means of our research study. So this is the initial characteristics of the thing. And then this can be available in the Google Scholar. If somebody is interested, you can look into it and you can refer for further more information with respect to this study. And we are trying to connect the cost aspect also in this particular study. Presently, the study is in progress. And this is the thing which got published in the research journal. It is a very famous and good high impact factor research journal. We have published this particular thing. So how the building material can be converted into building banks, that is material banks, and how the circular economy can be implementable and made into a reality. Yeah, these are all some of the references. So I acknowledge the BAMB, that website, which is giving a lot of information and a lot of input with respect to this circular economy and how that material can be converted into a material passport and building blocks. So I thank my research scholars and also the management of NICMAR for permitting me and also for supporting me in this initiative and to be one of the member of this panel discussion. With this, I am concluding my discussion. So hope I have covered all the aspect with respect to the circular economy, resource recovery, and also the waste management. So once again, I thank the organizers. Now the forum is open for questions, if any.
Thank you, sir. Thank you for the valuable insights which you gave now. So the question session will be at the last. So now I request the second panelist. I'm happy to introduce him. So it is my honor to introduce our esteemed second panelist for today's technical lecture, Dr. S.T. Ramesh, sir, a distinguished academician and research in environmental engineering. Dr. Ramesh holds a bachelor's and master's degree in civil and environmental engineering from Government College of Technology, Coimbatore, and earned his PhD from IIT Madras. With an illustrious career spanning nearly 2 decades, Dr. Ramesh currently serves as a professor in Department of Civil Engineering at NIT Trichy and holds the additional responsibility of Dean Academics. His expertise encompasses water and wastewater treatment, waste management, environmental impact and risk assessment, and the development of innovative environmental technologies. Dr. Ramesh has made significant contributions to academia and research with 98 publications in reputed international journals, over 100 conference papers, and a Scopus H index of 31 with more than 2,900 citations. He has successfully mentored 8 PhD scholars, 95 MTech students, and 15 BTech graduates. Beyond research, Dr. Ramesh has played key role in national initiatives, including serving as the national coordinator for JOSA, CSAB, overseeing the engineering admission across premier institutions like NITs, IITs, GFTIS. He has also been an expert committee member for Swachh ranking of higher education institutions and Smart City Advisor Forums in Tamil Nadu. Dr. Ramesh has played a pivotal role in national initiatives, serving as an expert consultant for smart city projects across Tamil Nadu, providing technical expertise in biomining, landfilling remediation, and waste vulnerization. His technical guidance has been instrumental in transforming legacy waste sites in cities such as Tirunelveli, Salem, Erode, Thoothukudi, and Trichy, turning waste into valuable resource while mitigating environmental hazards. His remarkable contribution to waste management and environmental sustainability have earned him prestigious honors, including the Green Champion Award from the Government of Tamil Nadu. Under his mentorship, the NSS and LEAP volunteers at NIT Trichy made it to the Indian Book of Records for their largest scale awareness campaign on plastic pollution. Dr. Ramesh is a fellow of Institution of Engineers India, a chartered engineer and an active member of several professional organizations, including the Indian Water Works Association and the Indian Geotechnical Society as well. He has also served an expert committee for environmental policy and waste management projects across Tamil Nadu, providing technical expertise for municipal solid waste management, biomining, and the sustainable urban planning. With his vast expertise in academia, research, policy making, and sustainability, Dr. Ramesh is a true leader in the field of environmental engineering. It is a privilege to have him with us today. Today, Ramesh will be sharing his insight on biomining, solutions for landfill remediation, and resource recovery in a circular economy, a crucial topic as cities worldwide with the challenge of waste accumulation, environmental pollution, and sustainable resource management. His expertise in scientific landfill closure, biomining, and waste resource strategies will provide invaluable perspective on how we can transition towards a circular economy and sustainable urban development. Without further ado, please join me in welcoming Dr. S.T. Ramesh. The session is yours.
Yeah, thank you, ma'am. Thank you so much. Yeah. Ma'am, can you please allow me to share my presentation?
Yes, sir. Dr. Sudarshan, sir, will you exit your presentation, sir?
Yeah, I already.
Yeah, Sudarshan, good morning.
Yeah, good morning, sir. How are you?
Yeah, fine, sir. Fine. Thank you so much. Yeah.
So still we are viewing your slides, sir.
Oh, okay. I will.
Can you please ensure my rights also, ma'am? Because I've joined in your account.
Yes, sir.
Hello.
So still we are viewing your slides.
Wait, I'm trying, but it is not permitting me. Done?
Yes, ma'am. Yes. Yes, sir. Yes, sir. Yeah. Yeah. Ma'am, then you have to ask, I think you have to allow me
Sir,
to
now
share.
you can try, sir. Now you can try, sir.
No, it is not.
After more than 15 years, I am seeing you, sir.
Yes, sir. Thank
Drastic
you.
change.
Yeah, thank you, sir.
Great.
Thank you so much. Yes, sir. Yes, sir. Ma'am, that option is not enabled so far.
Sir, now you can check, sir. And you have received one more mail from
Yeah, let me.
REA.
Yes,
You
ma'am. Yes, ma'am. Now I
can
could. Yeah.
join.
Yes, ma'am. Yes, ma'am. Yes. Yeah. Now it is okay, ma'am. Is my screen visible?
Yes, sir.
Yes,
sir.
sir.
It's visible.
Yes, sir. Yes. Thank you.
Thank you, sir.
Yeah. Yeah, I think this is fine. Yeah, good morning. Very happy to see like IEA members and also the session experts. I'm very happy to be here, the part of the one-day seminar or webinar kind of. So let me share some of my experiences, what I have done through for the waste management activities in Tamil Nadu, and how it is possible to implement on a larger scale in sites. That was my learning experience throughout, I think, 3-4 years. It started before Corona, but now we could able to meet out the demands of the government initiatives like landfill mining and also capping. So let me start my presentation like biomining solutions for landfill remediation and resource recovery in a circular economy. There are two challenges in solid waste management systems in cities and towns. One is about managing the continuous flow of solid waste on daily basis. That's a tedious task, and the corporations and also initial urban local bodies, they spend a lot of money and also energy on these aspects. I guess urban local bodies, they spend almost 70% of the money only for collection and also transportation, very little amount of efforts with the disposal options. But anyway, now it is also picking up decentralized plants and energy recovery plants and so on in the metro cities, but yet to come with urban local bodies. And another important fact is about most of the urban local bodies and corporations, the dump site, it has reached to a maximum level. There is no space to accommodate the waste, thereby dealing with the legacy of neglect, which has resulted in a garbage heaps have been built up at dump sites that were meant for waste processing and all landfills. So two typical tasks with respect to waste management. One is about daily management of solid waste. Again, one is about management of the legacy waste. And dumps have grown larger and higher, becoming a point source of pollution. That's everywhere they were started looking into. Dump sites are the major source for generation of greenhouse gases, especially on methane, and which will contribute a greater addition to global warming. And there are a lot of incidences here and there. Migration of leachate into a groundwater, which obviously pollutes the groundwater, and frequent fire outbreaks at the dump sites lead to air pollution. So we would have also heard about so many difficulties in urban local bodies, especially in the cities and also other small urban local bodies, is with respect to leachate and also the fire outbreaks, very common in the open dump sites. These are all the possible threats posed by landfill. I think those are already familiar with the system. We don't follow anything on the landfill for solid waste disposal. We call simply as dump sites without any liner or daily cover at the daily closure. And because of that, ends up with a lot of the leachate generation, infiltration of rainfall into a system, leads to generation of leachate and migration to the groundwater. Groundwater contains so much amount of the pollutants, and normally the leachate characteristics depends on the type of waste you dispose into a dump, which includes very recent studies. They have also demonstrated the components like phenol, toluene, benzene, and polychlorinated biphenyls, ammonia, dioxins, and chlorinated pesticides, metals, and other chemicals into the groundwater. And there are a lot of threats with respect to open dump sites also. Very recently, National Green Tribunal, they have alarmed that incremental growth of MSW waste, and these waste are converting into a virtual mountains. That also you would have noticed in your cities or in urban local bodies. So it has been permitted to go up to 20 meters of height, and it has become now virtual mountains. And NGT has directed the government to follow Clause J of Schedule 1 of Solid Waste Management Rules 2016. And NGT has directed Central Pollution Control Board to propose a standard operating procedure for implementation of biomining and bioremediation of legacy solid waste. That is, they are given very logical directions to Central Pollution Control Board. In turn, CPCB, they are given a very nice standard operating procedure, how to handle these legacy waste, which is lying idle for a long period of time. And they've also given recommendations for biomining and also bioremediation of legacy sites. And I'm not very familiar. I think you should know rules and regulations of solid waste management 2016. And at least time permits, you can also read. It has clearly spelled out how do you manage and how to manage the legacy waste very effectively, and also the different fractions with. So let me highlight the important duties and responsibilities of local authorities and village panchayats or urban agglomerations, and highlighting only the important points with respect to solid waste management rules 2016. It clearly says about the local authorities and panchayats investigate and analyze all old dump sites and existing operational dump sites for potential for biomining and bioremediation. Wherever this is feasible, take necessary actions towards biomining or bioremediation of contaminated sites. It's already mentioned in 2016 rules and regulations. If the biomining is option is not possible, and they also recommended to go ahead with scientifically closer or cap the landfill, thereby you can also prevent the further damage to the environment. So these are the two clauses. Thereby the different government, especially Tamil Nadu, Kerala, and Andhra Pradesh, and all the parts of the country, they have started looking into biomining as well as or landfill mining or capping as a better options to take care of the legacy waste and other things. So this law, it has also been mentioned in the regulations very clearly. This is not only for urban local bodies, it is mentioned with outgrowths in urban agglomerations. That is, they should also adhere to these rules and regulations. Cantonment boards, panchayats is very common. Industrial and also institutional townships, railways, and defense establishments. So this, whatever I have discussed earlier in a subclass, it is also meant for these organizations as well. And they are mentioned very clearly in a Schedule I, J, with closure and rehabilitation of old dump sites. It's very clearly mentioned that any dump sites or any waste dump sites which have reached their full capacity and which will not receive any additional quantity of waste after setting up a new or any properly designed landfill, and they should go for either reduction of already the legacy waste to go ahead with the mining process, and followed by a placement of residues in the landfill or in a capping. So they are mentioned very clearly. And capping with the solid waste cover or solid waste cover enhanced with geomembrane. And now open dumping is not at all feasible, and they are given very clear-cut definitions to either collect the greenhouse gases or to flare the greenhouse gases. And capping, as in serial number 2, what I mentioned earlier, above with the additional measures, you can also plan cut-off walls, extraction wells for pumping and treating the contaminated groundwater. Or that proposed body, they can also recommend any other method which will reduce the environmental impacts. So this is very clearly mentioned in the regulations. Now it has become a gazette, and urban local bodies has to mandate these the requirement which is mentioned in the Solid Waste Management Rules 2016. And it is very clear, and they have mentioned two logics. You just go for a bioremediation and biomining. And before that, you just make sure that you should also go with the survey and assess the total waste which is lying idle in a legacy waste dump site. That's what they are given. There are a lot of challenges to go ahead with total station survey or with a drone, and it is somewhat difficult to go ahead with the dumped waste which is below the ground, and there are a lot of challenges. Some places it is being disposed in a quarry or in a low-lying area that even we may not in a position to showcase when it has started and how to go ahead with the quantity assessment, because after finalization of the project, for example, mining or capping, then the payment to the contractor is based on the volume. It is very, very difficult to go ahead with the volume estimation. And they have mentioned very clearly, you can go either total station survey or drone mapping. And then they also mentioned you just go for a precursor study with the history of the site and extensive study on the composition analysis. Thereby you can recommend either mining or capping. So that's what the logic they are given. And they have also mentioned very clearly that you should follow some of the normal parameters to study the existing condition, or we call it as baseline studies, which includes the soil, which has already been contaminated with heavy metal, and thorough analysis of water. And you should also be familiar with the rainfall details in a particular locality, and soil type and surface hydrology, topology, and also wind direction. this shall be studied before and after biomining process. So these are all some of the essential prerequisites they are mentioned in the SOP as well as the regulations. And it is also been mentioned, you should also follow a periodic study after the completion of the mining process to check if any adverse effects with the surrounding area because of these effects. So that's what it is mentioned very clearly. And they have also given some sort of recommendations like mining is very easy. For example, that they have recommended, you just go for a simple excavation and go for simple stabilization of the waste through some sort of bioremediation techniques or by adding some sort of biocultures. And after that, after biostabilization, you can take it to a trommel mill and you can segregate the materials in a recoverable format or valuable resources, predominantly organic fines that we call it as soil-like material, bricks, stones, plastics, metals, and cloths, and followed by sustainable management of the waste, whatever it is segregated from our legacy waste through recycling, co-process, and also road making. This is very, very in a clear-cut manner, they also mentioned. So by attempting these problem statement, we have to be very cautious because it's already lying in a area where it is the compacted density of the solid waste is about 1 ton per meter cube. For the excavation, then you have to disturb the solid waste. Once I disturb the density, loose density will become 0.6 or 0.5. Some cases we found difficulty in 0.45 tons per meter cube. And once you disturb, it will become huge in volume, and handling this huge volume in terms of legacy waste is very, very tough. So it is somewhat very difficult to fix. How to go ahead with the mining process for a larger site, especially for Trichy and other Erode and so on. We did not have any spaces to have mining activity and even to store segregated material. This is very big challenging with respect to mining projects. So these are the processes or steps they have mentioned very clearly. Just go for excavation and stabilization of the biomass. And we felt all the legacy waste has already been stabilized or partially stabilized. There is very little scope for further stabilization with the organic matter and completely remediate with the augmentation of microorganisms and so on. Remove the moisture and bring down to less than 20 or 25% and take it to a trommel mill. And they have a set of sieves or the screen openings where you could separate these materials in a segregated manner. Thereby, you could be able to go for sustainable practices through recycling and also co-processing. That's what they are given. Yeah. So this is the overview, and I think in the SOP they have mentioned very clearly, mining, okay, you can start, no issues in that, but before that you have to stabilize the complete waste which is lying on the site by adding biocultures, or you can blow some sort of aeration. You enhance aerobic degradation of the organic matter, then go ahead with the screening of waste. And they have also mentioned, based on the components and also the composition of the solid waste, they have recommended different types of trommel mills, starting with greater than 150 mm, 80 to 100 mm, 30 to 50 mm, and less than 30, and also 6 to 4 mm. And there are two major fractions. So whatever it is being given more than 150 mm, I could be able to make it very easy because these sizes are very big. And 30 to 80 mm, that normally it goes directly to industrial needs as a supplementary fuel. We call it as refuse-derived fuel. And sometimes it needs shredding, or sometimes it may go with the raw material, whatever it is segregated from the legacy waste. And then, again, the major challenge is about managing very less size fractions, that we call it as like soil-like material. And some people, they may say this is bio-earth. And they also recommended to go ahead with the landscaping or soil conditioner, or you can give it to a farmer, you can use it for. So we felt this is somewhat difficult to manage with landscaping or the land disposal, because this is, if at all, any possibility for contamination because of infiltration of again into a rain, and it leads to a lot of groundwater problems and so on. So we had some devices, or we have devised a policy to go ahead some sort of other system. We can also make some sort of a circular economy. And the handling with RDF is again a bigger task. Again, imagine our situation after legacy waste is mined out, and if it has been lying idle, and management of huge volume of segregated RDF is a task. And it has been given recommendations to give RDF to a cement kilns nearby. Thereby, they may use as a supplementary fuel. And in the cement kilns, moisture is a major factor. But if it is more than 30 or 35, it is very difficult to give it to the cement kiln. And sometimes the demand with RDF, it is compromised based on the other supplementary material what they regularly receive to the cement plants and so on. So these are all some of the difficulties we have faced. So logic is very simple, and just mine the legacy waste, go for a stabilization, and simple screening methods, segregate different size fractions, and if at all anything with calorific value, and give it to a cement kiln. If you are possible to segregate plastics better, you can also go ahead with the road making along with the regular bitumen, and soil-like material can be handled filling the low-lying area or into building blocks and so on. So this is about the this what I've explained earlier. The first step is loosen the solid waste that I already mentioned to you. The existing legacy waste dump sites, the compacted density is about 0.9 to 1 ton per meter cube. Then for the stabilization actions to happen, you have to loosen the solid waste. Then you have to bring down the density to almost 0.5 to 0.6. You have to loosen the solid waste. Imagine our situation, if you loosen, then automatically volume is one factor, and it is possible to infiltrate, if at all, any heavy rainfall in the system. Challenging with managing with the solid waste during rainy days was very, very challenging. And then the second step, and to enhance the stabilization activity, for some cases, there could be a partial degradation of solid waste, and you can also add up some sort of biocultures and enhance the composting process. Thereby, it claimed to be a bioremediation, and you can also dry enough the segregated solid waste after bioculture or biostabilization, and it is amenable for screening and so on. This is the second task. And as I mentioned earlier, and the stabilized waste after the complete stabilization of the organic matter is bring down to a trommel milling operation, and where you may use different size fractions starting from 150, 80 to 100, 24 to 50, 12 to 16, and 4 to 6. Thereby, I could able to separate large amount of materials, so on. The finest material that is called bio-earth, as I mentioned earlier, or we simply now called as soil-like material, because it is similar in all respects, but only is not a soil, but it's a soil-like material. And coarser fractions like brick, stone, coconut shell, foodware, cloth, and other larger particles or plastics will go directly to recycling agencies. And there are in the plants, we also had density separators. We could separate the combustible matter almost is 5 to 10%, which is in the legacy waste. Then lighter fractions, as I mentioned earlier, mainly on predominantly plastics. Maybe it lost its value or it may have something. And the government also given recommendation that can be used in the hot mix plants. Thereby, it can also be laid in the roads, so-called plastic roads, as you would have already heard about. And the major portion, what I use the word refuse derived fuel, it will directly go for co-processing in the cement kiln. And if it is more than 50%, more than 50 mm, it may require shredding. Less than 50 mm, you may not require any shredding, directly packed and given to a cement kiln for complete destruction. And heavier fractions, as I mentioned earlier, there are large amount of materials in the heavier made fractions. And sometimes it will also go for landfilling and so on. And getting into a site, for example, they also mentioned different types to stabilize the organic matter. Without stabilization and segregation is not at all feasible. And if I do a segregation again further in turn, it may create a lot of problems on the environmental degradation. So they are given different logics to go ahead the stabilization activity. Number one, biomining through a tractor tiller by windrows in the site itself. Or you can go for a biomining through a trench method, or they may go biomining through a cone, or they may also insisted upon to go ahead windrow method for very spacious landfill sites. And last one is about you can also spread over the legacy waste by thin layer 1 and above. Okay, and by looking into the points, it is very easy. But if you get into a real site, and the stabilization of the biomass is very, very challenging task. Imagine our situation in Trichy, we have almost 47 acres of the land, and we don't have even a space to have the different formation of windrows to stabilize the organic matter. It's a big challenge. And these are all the schematic representations, how you can go ahead with the windrow formation. And in the right side, I think you could be able to see the windrow formations in the site. There I could be able to stabilize the organic matter by loosen the legacy waste. So you can make a legacy waste to a depth of 150 mm, and you can mid-spray, you can spray biocultures, and if at all anything on the larger objects, you can hand pick up and make a windrows for remaining waste. Turn the windrows for 5 to 7 days. After 6 weeks, then you just may go for a simple screening methods. And it has also been mentioned, you can not only 150 mm, you can also go for 1-point trenches. Almost is 1.5 meter to 2 meter deep. And you can also have a trench up for 2.5 or 2 meter or 2 to 2.5 meter in the site itself. You can spray the the biocultures in the trench, and then you can form a windrow and turn the windrow for 5 to 7 days. Then after 5 to 6 weeks, that these stabilized biomass taken into screening area for segregation of solid waste. And cone method we have tried in Trichy because it is easy to have. You can drop the solid waste from 2 to 3 meter height and form a cone, and mid spray you just spray the bioculture, and every 2-3 days you just turn the cone to aerate, and after 5 to 6 weeks you do for simple screening. And this again windrow method is very common. You can, if the landfill site allows you to go for parallel windrows throughout the if it is anything on vacant site or vacant areas available, then you can form a simple windrow and turn the windrow on a weekly basis. And you can also mix 2-3 windrows together. There we could able to expect a volume decrement, and after 5 to 6 weeks you can go for simple screening methods. And thin layer, again, if the landfill site meets out your space demands, you can also plan for layer by layer. This is again, you just spread over the solid waste, legacy waste layer and layer above, and turn the windrows, and then mid spray the bioculture, and after 5 to 7 days, and go for a complete turning in. And after 5 to 6 weeks, then you just go for a screen. So this is the complete sustainable disposal of the legacy waste they mentioned very clearly. Then just go for a simple screening after stabilization of the organic matter, and you may get 5 or 6 components as it is mentioned in this slide. Oversized component, and good earth or soil, as I mentioned earlier, soil-like material and ferrous material, and light and medium fractions. And we could find the different types of plastics in the legacy waste, and heavy fractions, for example, construction and demolition waste, and non-ferrous metal. And they also recommended to go ahead with the recommended disposal options also. Oversized material, again, it will go for a secure landfill operation. Soil-like material, if it is a good, maybe with the nutritional value, it will go for landscaping or farming or soil conditioner. Ferrous, it will go for recycling, and plastics will go for RDF in a cement kiln. CND, it will go for again recycle and also crushed and used on site. And non-ferrous material will go for recycling. Okay, so this is the model we have followed for, I think, most of the cities what I've experienced in Trichy, Erode, Tuticorin, even Tirunelveli and also Salem, and we have done for a capping process. And this is the typical model where you could able to manage the complete legacy waste without much difficulty. And the MSW dump sites, or we may simply call it as abandoned sites or a legacy waste, and which is being enhanced by bioremediation and also biomining activity by appropriate agency appointed. And we may get different products like RDF, recyclable, and compost, and the inert material what I mentioned, soil-like material, and the recommended disposal options like cement industries. Recycle will go for respective authorities, and compost will go for landscaping marketing, and rejects either it may go for a low-lying fill and some sort of scientific landfilling activity. So thereby I could be able to close the continuous the representation as an operating model. So that's what it has been recommended. We have followed these model into different sites. Okay, so let me go. Then probably you may appreciate later and what the effort we have taken into the biomining activity for some of the sites. I may be presenting phase 1 results and also studies what I've experienced in Trichy, but not all together. But it is a project is still going on, and we are also making into a circular economy kind of a thing. Then we are going for technology transfer demonstrations and so on. Probably I'm not able to share these details, but whatever we have done in biomining activity, I'll be sharing with. Site investigation study area I would have heard about. It is on the highway, Ariyamangalam. It is almost 13 or 14 kilometers is away from Trichy, that main area. Its population, it is as per 2011 status is about 9.17 lakhs. And total waste generation is about 450, and now we are reaching about almost 550 to 600 metric tons. And total waste collected is about only 80%. And method of collection is about door to door, and disposal only to a landfill dump yard, they call it as. or otherwise it is named as Ariamangalam Compost Yard. Earlier it was a compost yard, now it is turned to a legacy waste storage. And Trichy in particular, they have insisted very importance with the door-to-door collection. Only the leftover material which is not biodegradable, it will come to a site. Others, it will go directly to a decentralized composting facility. They have, I think in the city, we have almost 55 to 60 decentralized composting yards. And 47 acres, it is adjacent to a highway. And the phase 1, we have assessed 7.1 lakh cubic meter of solid waste, and it is extended to phase 2. And phase 3, we are given a technical report to mine the solid waste below the ground. The average height of the landfill site is about 5.6 meters. And we have taken direct sampling, and we have observed there is no daily or intermediate cover over the waste heaps, and there is no liner at the bottom. And water table, it is below 6 meters. So this is about the site investigation. Now you can look into the dumping site, and it is almost a legacy waste. Almost is, I think it has started way back in 1984-85, and almost is 30 or 35 years old, and completely degraded, but it occupies space. And as I mentioned the word, it becomes a virtual mountain, a solid waste mountain. And we have gone with the systematic divide and policy. What it is has been mentioned in SOP, standard operating procedure by CPCB, and we had a lot of challenges how to assess. For example, in a regular the assessment, for example, volume estimations like sand or any mined material, is very easy. You can go for a simple trapezoids and kind of, but here it is about not very properly done as a trapezoids or trapezium kind of a thing. It is very, very difficult. So we have invited 4 or 5 different vendors to the site, and after seeing, it's completely packed with almost 47 acres of the land, and none of the vendors, they were not in a position to execute the survey. And I got a startup, and we have educated the surveyor and explained the typical tasks with the mission projects under Smart City, and they have given some sort of positive thought, and he has given me a status like that. So we have also gone with the strategic plan where you can identify a zone where the legacy waste is started. I mean, 85 something, we could able to identify the zones by referring the old records. We have divided the total 47 acres into 4 zones, zone 1, 2, 3, and 4. And we have gone with the typical survey with the total station, and we could be able to assess almost 7.5 lakh cubic meter. I guess it is I think pre-feasibility study report we are given in 2019, just I think 2018, just before the corona, and we could able to, and we have demarcated with the boundaries with zone 1 and zone 2 and zone 3, and with the volume. So with the volume, this and the first step successfully completed. We have taken almost 1 to 1.5 months to fix the boundaries as well as the different viewpoints and high points in the top of the landfill area or legacy waste dump area. We could able to pick up the points, and we could able to plot and assess how much is the quantity of the waste, whatever we have got. And the second important task is about I have to convince the administration, like we can go for a mining. So the typical task is if I do a mining, I could able to recover as much as possible, and we can give it to a reclaimed land to a corporation. Thereby, the 47 acres of the land can be used for some other purpose and so on. And solid waste sampling, as it is mentioned in some of the literatures, they say simply go for a simple auger boring, or you may go for a machine boring, or you just go for a simple open pits and so on. So none of the techniques will be useful, and it is very, very difficult. And we have gone a maximum almost is 3 meter level with the buckline, and we could able to take up the samples with respect to 1 meter interval, and labeled and brought back to the institute and taken consideration, and we could able to assess what is the composition of the past deposited waste, for example, maybe 15 years and 20 years and so on. And then we have also characterized the solid waste with respect to identified. So dealing with fresh waste is something is easy than that of the already deposited solid waste, because this legacy waste may have a typical components and typical parameters with respect to the depth. That is very challenging. So we have brought to the laboratory, and we have done extensive segregation practices, and we have gone through the literatures, what it has been followed in developed nations, and we have now come to a conclusion like the percentage distribution with respect to depth, and it was like the appreciable positive outcome we could able to observe. Like almost 25 to 30% of the resource recovery material, and other than that is large amount of humus. Humus is initially we have started, but now we have changed into a new terminology called soil-like material. And most of the cases with respect to 1 meter and 2 meters and 3 meters, and we could able to see considerable portions of the recoverable material, for example, which recoverable in the sense is the material which may have some sort of calorific value that can be easily managed in a recommended cement kiln or in a thermal exposure. That's what our logic. And we have also projected the data with maximum and also minimum with respect to different fractions. And I think you could able to see on the left hand side different composition. This composition is not fixed. With respect to depth, we could also find different fractions, and we have demarcated with the different composition and projected, and we have also gone with proximate analysis and also ultimate analysis to showcase, yes, I can go for a mining activity, and after that I could able to take up some of the important refuse derived fuel and also like the soil material, which can be further taken into other consideration. That was our objective. And NIT Tiruchirappalli has given a feasibility report as a new like the logic to Tiruchirappalli City Corporation, because the waste to be managed for a phase 1 is about 7.5 lakhs cubic meter. And we have projected this data to the government, and with the possible approach what we have presented, and the government, they have almost has given a logic. Yes, we can go ahead. We'll take 1 or 2 urban local bodies like a corporation as a sample, and they have allotted almost is 49 crores to Tiruchirappalli City Corporations to execute biomining activity. So the main point is about that is very easy to go, but even we have a lot of challenges to go ahead. So that what's the logic they have mentioned. And the biomining that with this data, and we have got the money, but we have also like the corporation has identified the vendor, and vendor also is very new to the system, and we are bringing some of the new logics to the waste management, and we also supported the vendor in terms of technical. And one fine morning we have started the biomining activity in the site. The major task here is it is very it was no space to even sometimes to plan a 150 or 200 metric tons per day of a biomining plant. It is very, very difficult. So we have relocated one portion of the solid waste to other area. I mean, we could able to establish one initial plant, I guess, to 30 tons per day. Then subsequently it's been added, and after Corona, and for the complete closure of within complete like legacy waste to the maybe with the road level, and we are completed within I think 2 years with a specified target level of almost 1,000 tons in a day, and we could able to achieve within 2 years. We now the 47 acres of the land is being completely recovered. So this is the inauguration. And whatever in the place you are seeing on the right hand side, this is about the reclaimed area, not reclaimed, it's a relocated area where you could able to like we could able to install the plants of initial plan number 1. And then it has been added up with 3 plants in total in Trichy, and it has reached up to 1,000 metric tons per day of legacy waste in a day. So this, I think now you can see these are all the plants whatever we are installed, and this is the initial conditions in the dump site. Whatever I have discussed earlier, all our 4 or 5 methods is not. It is very difficult to implement in the real field, and we have followed windrow formations by cone method. That's what it was feasible. Then cone is very simple. You just disturb the solid waste and take it to almost 1.22 meters height with the book line and drop it. Thereby, there could be a the complete legacy waste will be loosened up. Then there could be a chances of like the oxygen entry or aerobic conditions in the system. Then you could also expect some sort of degradation, and you could able to see like a lot of smokes which is comes in because it's already with the compacted density of 1 ton. And if I loosen, there could be a possibility, and there are heat inbuilt also. And we had a lot of difficulties, but luckily we did not have any fire, but we had a lot of difficulties in operation. And we have formed windrows like this by a cone method and windrow turning, because we are also new to the systems earlier, and we could able to achieve at least complete stabilization and Without sterilization, if I take it into a mining plant, and there are a lot of chokes because the screen will choke and process cannot be taken further. And we have understood the situation, and as much as possible, eliminate the moisture content at up to 20%. And some cases we also sprayed deodorizer because it is near to the highway. Once you disturb the solid waste, there are inbuilt or the inbound gases which also emanates from particular legacy waste. It creates a lot of nuisance, and we have used deodorizer and bioculture in between, and to stabilize the organic matter. We have also done that. And after, say example, the stabilization, it is brought to a mining plant where you can do a mining. So here the problem is about how to quantify the material again, because it's the payment to the contractor is based on the volume or the weight. Okay, so initial periods where they did not allow for a weighing basis, but they've asked us to go for simply the volume methods. So in terms of meter cube, payment to the contractor or the vendor, it is being paid through a meter cube aspects. There were a lot of challenges to quantify how much amount of it is the legacy waste being mined and also like segregated, and we have also devised, and in the site we have also completely automized everything, and each and every truck what it is comes into the biomining plant, this is being captured with the video, with the photograph, and inward registrations with the vehicle number, and they may go for a simple weighing and allow the truck to get into a biomining plant, and they'll also come out, they'll also get an empty weight, there way they'll get a trip sheet and kind of, and everything is completely been monitored with surveillance, and where I could able to monitor from my office also. So there way we have created a system, and completely the plant is being completely automized. Plant automation is being done by the vendor, and each and every set of operations, I think you could able to see on the right side, it is about the SCADA operation, and each and every like the conveyors, belts, and trommels, everything is on automated. Thereby, we could able to meet out the demands. And we also created ERP, where I think you could able to see the vehicle number comes in, trip sheet, and what time they were entered into a system, and what is the empty weight of the truck, and loaded with the truck, and they'll also get the net weight. And net weight is again converted into terms of meter cube. That's what I told you, because is a payment to the vendor is by the meter cube terms. So even Swachh Bharat Mission solid waste management rules, they have mentioned the legacy waste compact density, even though it falls in 0.7 to 0.8, some cases is 0.75 to 0.85 also, but we have ensured that each and every vehicle, that what is the compact density, the loose density, by taking the samples in the individual trucks. So we had a big team, and they also monitored every truck, what is the density of the each and every legacy waste brought into a mining plant. Thereby, for me, it is easier to convert in terms of meter cube and recommend for payment. This is a procedure we established, something similar to a small box of 1 feet cube. And then smaller may not be very sufficient. Then we may convert into 1 meter cube box, repeatedly weighing multiple times, where you could able to find out what is that the density of the sample. And now you could able to see and appreciate our efforts. I think whatever you see on the right hand side is the highway. It's completely on with the households, and the demarcated area that is been identified as zone 1. And whatever you are seeing with the sheds, initially it was this compost shed. Then I think you would have also noticed here, these are all undisturbed solid waste, and we have started forming the windrows completely by the methods whatever is specified in CPCB SOPs, and we could able to manage. Imagine our situation, I could able to make my plant to work for 1,000 tons per day, then almost is 30 or 45 windrows with 1,000 tons will be ready for subsequent operation. So we have managed with effective inventory management, we could able to. So the plant have almost is run 365 without much difficulty. We had very short breaks during only the Corona period, lockdown period, and beyond that we operated without much difficulty. Okay, now you could able to see how the zone 1 is being changed with now you could able to see with the dark brown color. These are all the disturbed solid waste, and here and there you could also able to see a lot of windrows is being formed. Okay, and these are all the mined fractions. One is about bio-earth, that soil-like material. These are all unshredded RDF, and which may have some calorific value. And these are all shred. Some industries, there are requirements. They may also ask us to provide raw shredded unshredded RDF and also shredded RDF, and based on the requirement, it will go off. Okay, this is the soil-like material that is a big challenge for us because it's imagine now once disturbed, 110 remains as 110 without I think there could be a changes in the moisture content, weight will come down. So 110 to 0.8 tons and 0.8 tons in again in the segregated form. So I have to plan very effectively the management of inventory, whatever this comes in. And we have also given a deadline, and the vendor has to clear the sites without much difficulty, whatever it is being like mined out within the maximum period of 1 month. So then only the certifications will be given, and vendor is recommended for payment and so on. So this is again big challenge for us. And now you could able to see different mining fractions like PET bottles and footwears, glass and tires, stone, metal crafts, and big boulders, and stainless steel, and so on. That will be given to the respective recycling vendor. Then without much difficulty, it will go off. I think it may have some sort of recyclable value. It's possible. So RDF loading, imagine our situation, Trichy is nearby. Trichy, we could able to attempt a lot of cement plants is nearby, but some cases of cities is somewhat difficult to send this RDF. It also again leads to a lot of transportation cost. Trichy is lucky enough, and we could able to meet out the demands with respect to Arielur and also other nearby cement plants. And even we are also in a position to send these RDFs to Maharashtra if it is huge and peak demands. Okay, this is the RDF loading to the cement plant. And again, it's a typical task. And again, because these are loosened material, it's somewhat difficult to go for a compaction. And somehow we could able to manage and send it to a cement plant. And there are some of the density measurements, because the small box for a vehicle is not okay. And we also demonstrate with each vehicle. So in the site, there are, say example, 5-6 vehicles, and they may also go for a repeated loadings. And the main problem with this vehicle density measurement is about I may not be in a position to fix, even though the volume is known. It is somewhat difficult to fill the legacy waste to a required some sort of rectangular or in a full format. It's very, very difficult. So we have gone with the approximation, and we have also established with a clear-cut maximum and also minimum density of the solid waste with respect to the system. That is this almost is 640 kilogram per meter cube to 870 kilogram per meter cube. So average density for trial and error basis, we have fixed with almost 0.7. So with that, with extensive density measurements, now government has agreed to have some measurements. Now I guess it has been changed to a weight basis, not in a volume basis. They may pay to the contractor or a vendor in a metric ton basis. That's what now it has been recommended by the government. And RDF also, we have checked the density of the RDF before getting into a cement plant. We had some trials, and we could able to check and so on. These are all the mined fractions, and we are showcased in different forums. And it was very challenging for me to execute the task, because this money has been given to the corporation, and the vendor is being fixed, and the monitoring agencies is by NIT Tiruchirappalli. And we had very, very hectic time to learn and implement it onto a field. That is very, very easy, because conceptual way of learning, it is something different, but actual implementation to a field is very, very tough. I mean, we could able to manage, and we could showcase these different logics to different people with the municipal administrations of Tamil Nadu, and then secretary, and then DMA, and they were completely appreciated, because this is technical institutes like NIT Trichy has been taken care of nearby site. That's what our appreciation. And now you could able to see the site views of what has happened in 2020. I'm not in a position to give all photographs, but I have taken year-wise, January 2020 and 2021 and January 2022 and September 2022. And I think almost the phase 1, sorry, area 1, zone 1, zone 2 and zone 3, and completely been reclaimed, and the phase 1 is completed. And after phase 1, and by seeing the success of this landfill mining activity, again the government has proposed to go for a phase 2 mining, and phase 2 also we have completed. And phase 3, after phase 2 completion, that means this all 47 acres of land is completely been removed. And there are a lot of, even because 47 acres near to the highway, it is very difficult. But urban local body, especially on some of the municipalities or corporations, they were not in a position to find other sites for disposal again. It's very, very difficult. So Then this site has been identified for other projects like warehouses, and even for a reclaimed land can be with other maybe with recreational purposes and so on. And we are recommended to go for the mining of the solid waste which is below the ground as a one go, thereby completely say that it's completely been reclaimed. We may not have any problems with any contamination or migration of leachate into the ground and so on. So that we have recommended in phase 3. And there you have a lot of challenges. Again, how to monitor or how to take a measurements below the ground. That was the bigger task. And we have devised a mechanisms called resistivity survey method, as other soil mechanics people they approach. And we have gone with the resistance with respect to different solid waste, and made a profile with respect to resistance, and again made some sort of a below ground level, and we could able to now showcase. So this is the site 1 phase 1 result, and we have cleared almost 7.5 lakhs cubic meter. Phase 2 again 3.5 lakhs cubic meter. 42 or 41 acres of the land is completely been reclaimed. Now we are waiting for the options to go ahead with the phase 3 and below the ground to mine level. And this is the fraction I've already mentioned to you. Like there are percentages like 16 to 17% of RDF, and the 50% is again the soil-like material. 30 to 40% is soil-like material, and other fractions and so on. So, so we have demonstrated the process to the site, and the phase 1 completed, phase 2 completed, and phase 3 the unique method of like the measurements below the ground level we have showcased, submitted the report to the government. And the soil-like material we have taken into next considerations, converted into a block. Now it has been showcased in the different forums, and it has also been projected through some of the inventive, the startups and the technology transfer. Now I'm happy to say that we are also showcasing to the next level of making a product industry. We could able to manage like soil-like material into a converted product, and we also had a dialogue with like cement plants. Anyway, after like the RDF destructions, you may get ash, and the ash also can be converted into a building blocks and so on. So thereby it will become like a circular economy. This is my conclusion. Legacy waste, even though it is a lot of with ill effects, it is possible to manage by simple mining or capping. Anyway, capping I have not touched in, but there are a lot of challenges and also appreciable remarks with respect to challenges. And we have also demonstrated 2 projects in Tamil Nadu, one in Tirunelveli, another one is about Salem. And urban local body, that they should also have a management with respect to in-house and competent authority. And there are 5 models they have proposed to go ahead with these biomining concepts in the urban local bodies and also corporation. And various types of waste is being taken care. That is one from dry waste, soil conditioner, hazardous materials, biomedical waste, then construction is also demolition waste and e-waste and so on. And the logic is about the urban local bodies has to understand the accumulation of solid waste in a particular locality. They should also make a complete policies on collection, handling, processing, and also mixed waste. Now, the government of Tamil Nadu, they have given enough fund to all urban local bodies. I think most of the sites in Tamil Nadu, they have initiated biomining activity. One of the recent activities also, I guess, Chennai, they have started 2 major plants, dumping sites in Chennai. One is in Perungudi, another one is about Kodangayur. And I guess when Coimbatore also, they would have started the mining activity in major sites, Vellore and so on. And now I think they are given a target, and they could able to finish it off all legacy waste which is lying on in the site. And the urban local bodies have given a task to at least vacate the land, and you just make yourself to ready for taking care of the future waste, which is not recyclable. So that's what now the logics, and government also has initiated a lot of the waste to energy plants is in picture. Trichy, you have got technical feasibility report to go ahead with the energy waste to energy plant and so on. And so probably these days are not far away. Probably you could also manage our generated solid waste with a lot of technologies has been mentioned or whatever you have studied in different concepts. Probably in a short period of time you could be able to witness in different urban local bodies and also corporations. Yeah. So with this, I have submitted our credentials to Government of Tamil Nadu, and they have given me a champion award in 2021. I'm happy to be part of smart city initiatives in Tiruchirappalli, and now we are waiting for the better options for waste to energy plants, and conversion of these unwanted material, for example, soil-like material into a block, and even ash into a building block components. And we are also waiting for like some of the new initiatives and incineration plants as well in like Tiruchirappalli city. Yeah. So with this, I thank all my partners, like Government of Tamil Nadu. Thanks to Government of Tamil Nadu, and they have given me a thought, and also even they also given the huge amount of investments or money to urban local bodies and also corporations to initiate capping and also mining projects. And I was part of smart city member in Tiruchirappalli, thanks to Tiruchirappalli City Corporations. And most of the learning what I've gained is only through the practical implementation of these strategies. And thanks to NIT Tiruchirappalli, they have given me a lot of freedom to execute a lot of the government and also public interest projects in Tamil Nadu. Yeah, thank you. Thanks a lot. I take this opportunity to thank the organizers for giving me some sort of options to share my thoughts to these forum. Thanks a lot. If it is anything on the query, let me answer. Thank you so much.
Thank you, sir. Thank you for your valuable insights and initiatives for the public and government. Thank you once again, sir. The question session will be at the last. So now it is my honor to introduce our esteemed third panelist, Dr. K. Kannan, sir, a distinguished agricultural scientist with an impressive 27 years of experience in agriculture research. He is currently serving as a principal scientist and head of the crop production division at ICAR, Sugarcane Breeding Institute, Coimbatore. Dr. Kannan completed his BSc Agri and MSc Agri from Annamalai University and obtained his PhD in agriculture from Tamil Nadu Agriculture University. Over the years, he has contributed significantly to natural resource management and crop productivity, playing a key role in advancing sustainable agriculture practices. Throughout his illustrious career, Dr. Kannan has served in Nagaland, Odisha, Uttarakhand, and Tamil Nadu in various capacities as scientist, senior scientist, and principal scientist under the Indian Council of Agriculture Research, ICAR. His extensive research has led to 75 publications and 2 books, making a lasting impact in the field of agriculture science. Dr. Kannan's remarkable contribution has been recognized with the 4 national awards and 1 prestigious international award, and conferred by the United States Department of Agriculture, USA, for his outstanding work in the agriculture research and development. Today, we have the privilege to hear from him as he shares his expertise on circular economy for agricultural and environmental sustainability, offering valuable insight into sustainable farming, crop management, and the future of agriculture innovations. Without further ado, let's extend a warm welcome to Dr. K. Kannan. Please, sir.
Thank you, Dr. Priya. Dr. J. Krishnamurthy, Chairman, AEA. Am I audible? Hello?
Sir,
yes,
Please
audible, sir.
Yeah,
Yes.
thank you. Dr. Distinguished panelist, Dr. Sudarshan, Dr. Ramesh, and Madan Mohan, Honorary Secretary, AEA, and participants, good morning to all. First, when I was connected by Dr. Priya for giving speech on circular economy among the engineers, I was worried because being an agriculture scientist, how I fit into the crowd filled with all engineers, distinguished engineers. But environmental concern is everybody business, and food security also everybody business. So I thought I can give some insight into what is happening in agriculture concerning to circular economy. Because resources which are required for crop production is shrinking, be it land or nutrients and water, but population is growing. So we are in the position to produce more and more food with the shrinking resources like land and water. At the same time, our soil quality also becoming poor because of a lot of environmental activities and climate change. So under this situation, how this circular economy can increase the food productivity and sustain the environmental security and food productivity? I'll share some of my works. So I'm sharing. I'll divide into four topics. First, scope and principles of circular economy in agriculture, practices of circular economy in agriculture for environmental sustainability, practices of circular economy in agro industry, agriculture-based industry, and culture. I want to make it two broad aspects. First, how this practice of circular economy within the agriculture system can help the agriculture sustainability and environmental security. And second is how this circular economy in agriculture and agri-based industry can sustain both agriculture productivity and agro-based industry. The circular agriculture focuses on using minimal amounts of external inputs. As you know that the nutrients is supplied through fertilizers like urea, DAP, and all being costly, and most of the fertilizer we are importing our foreign, it costs our foreign exchange, and it has become very scarce. Closing nutrient loops, regenerating soil, our soil also being degraded because of soil degradation and erosion. So how to regenerate our soil using this circular economy, this is more important. And minimize the impact on environment. As we know that we are dumping many agriculture inputs in agriculture in soils. It's all going to affect our environment and all this chemicals leading to water bodies. And how we can minimize this through circular economy also very important. If practiced and wide-scale circular agriculture can reduce resource requirements and ecological footprints in agriculture, because whatever inputs we are using in agriculture, it has some both carbon and water footprint. We have to in pushing to drastically reduce the carbon footprint in agriculture because it contributes almost 13% of our global warming. Also, it can ensure a reduction in land use, chemical fertilizers and waste, which makes possible to reduce global CO2 emissions. In traditional linear economy in agriculture, always we make and use and dispose, be it all crops residues. But in circular economy, we make and recycle and reuse it. Not once or twice we can reuse it. There is no waste at all. Unlike another industry, there should be any waste when we follow circular economy in agriculture. Everything will ended in product only. These are the principles and practices followed in circular economy in agriculture. First, agroecology. Gone are the days when we use only one enterprises or only crop. If we cultivate, we only cultivate any crops like rice, sugarcane, or cotton. But in agroecology or integrated farming system, if we combine many agri-based enterprises like livestock industry and poultry industry, along with agriculture, the resource flows within the system that can be easily recycled so that we can minimize the external inputs. And it will benefit, it enhances the biodiversity and enhances the soil health, reduces pest and diseases when we follow agroecology approach that we'll cover later. Second, instead of any one crop, we can if we go for agroforestry, it means growing any annual crops like commercial crops or food crops with along with the tree crops. It will lead to improved environmental quality and soil quality and provides habitat and sequestered more carbon and stored in soil. And other practices, regenerative agriculture. it will increase the soil organic matter, water retention faster with diversity. Regenerative agriculture is nothing but instead of going for heavy plowing, because we go for agriculture, one of the main component is plowing soil with the tillers. If we go for heavy tillage, it lead to a lot of erosion, and it will reduce the soil health. Thereby, it will impact not only food security, also it will impact on environmental quality. So if you go for a minimum tillage with the intercrops and cover crops, more intense crops, it will sequester more carbon and improve soil health and reduce the environmental problems. Then closed loop system in agriculture, all resource flows within the system. One enterprises will give resources for other enterprises, so that we can minimize the waste, and it is energy efficiency and promotes self-sufficiency without bringing for resources from outside. All these practices based on the following principles. One is neat recycling. As I told that when we look for external inputs, fertilizers, it lead to more soil deterioration and environmental problems. But we recycle the nutrients within agriculture by growing green many crops, and again plow it to soil. It will enrich the soil, and use of certain microbial culture to fix the nitrogen from atmosphere. We can reduce the external fertilizer application. Thereby, it will reduce the environmental problems. As I said, it's also reducing external inputs at lowest cost and enhance ecosystem resilience. Biodiversity conservation sites support ecosystem service on farmers' lands. Waste minimization. There is a lot of waste produced from agriculture waste, like crop residue and produce residue, and it will be thrown in the open environment. It will cause many problems. So if you convert this waste into compost, it can reduce pollution and enhance resource use efficiency. And ecosystem health, supporting long-term agriculture and low productivity. And why we are going for circular economy in agriculture? Just to reduce external, first is reduce external reduce the external resources, but at the same time increase the health of soil, because without soil and water, no human being, any population exists in this earth. For that, soil is the major resources. All human beings exist around the soil. So soil ecosystem services are many. Is a provisional service that gives food, fuel, fiber, water, and gene food. All it gives. Then regulating services, it will regulate the climate by observing greenhouse gases and carbon sequestration. But sequester more carbon, because that terrestrial Earth sequester 2,500 gigatons of carbon from atmosphere, and this soil is the second most source or sink for carbon. And pest and disease regulation, supportive services like weathering of soil, nutrient recycling, provisional habitat, all it gives. Then cultural services like irrigation, tourism, a good landscape give always good tourism support. So this whatever we are doing for the circular economy, it will increase the soil ecosystem services. Let us see what are the practices we can follow in the first source conservation or circular economy in the mind spoil, like our earlier speaker spoke about dumping of garbage waste in land. Like this, in many places, soil mining is going on. But after soil mining for certain metals, they dump the soil in open area like hill, but no vegetation can grow because it will not support any vegetation. There will be low moisture. Moisture cannot be stored in the soil because of gravel soil and low organic matter, are almost waste soil. So nothing can be grown in this soil. So to bring back this mine's spoil, where certain techniques are there, like geotextiles. Geotech is nothing but you can see the open mat manufactured from either kayak industry or jute industry. We can lay on the soil and stop it in the mine soil. Thereby we can stabilize the soil, and it will support the vegetation. Or we can grow even fruit crops which will give habitat and food for animals and birds. And coming to region, circular economy, as I said that all we need for growing any crops, we need nutrient from fertilizers. Here you can see the sugarcane crop along with some green medium crops like dencha and sadap. The right side corner, bottom corner, you can see only sugarcane is grown without any crops, because sugarcane initial stages offer lot of space because it is slow growing. After up to 60 days,
Sir, you're not audible. Sir.
Hello.
Sir, yes, sir.
Sir, you're audible.
I think Kannan sir is not connected.
Yes, sir. Kannan sir, you are not audible, sir.
I think some network issue probably.
Yes, sir. I'll ask him to reconnect it.
Okay, okay, man.
Sir, he will rejoin back within 1 or 2 minutes.
Okay, okay, madam, no problem, no problem.
Been.
Yes, sir, you may connect, sir.
So which side, from side, as would you start?
Sir, from which way you stopped, you can start from there, sir.
Okay,
Till that we were listening, sir.
okay. So in sector economy in agriculture, usually we go for single crop only. You can see the bottom right where only sugarcane is planted. But the crop like sugarcane, which only crop up to 60 to 70 days, it will not grow quickly. It will there is lot of space available in this way between sugarcane crops. But if you leave it as such, then it will a lot of weeds will come, and where to go for any weeds chemical spray to control weeds, and it will lead to environmental problems. Same time, we go for some sudden crops like very short duration, very quick growing crops like leguminous crops. Means crops like pulses, green gram, red gram, sorry, green gram, black gram, or certain crops like danger. It will within 40 days it come to flowering, and you can see the bottom left portion. Sugarcane is there within 40 days with available space. It come to harvest, come to the flowering stage. There is no weeds are there, so no need for any chemical spray, and we can reduce the chemical needs. And also we can, if we can plow it, we can kill these cow crops. Then when we kill cow crops, it will add carbon to the soil and enrich the soil with NPK. And also it diversified the microbes available in soil, so the soil health will be enhanced, and entire agro ecosystem health will be increased. The standard cropping cover crop can sequester more carbon and fix atmospheric nitrogen and reduce chemical like fertilizer and spray like weedicides and pesticides, so that environmental really very safe. Also, it will increase the main crop yield. The main crop yield here is sugarcane. So we need not rely on external inputs. Thereby, we can save more import fertilizers. The circular economy, second purpose is converting agricultural waste into wealth. In certain crops, a lot of byproducts will be produced, like in sugarcane, and sugarcane is only a crop. From 5th year, we have to remove the leaf, because the crop should have only 10 leaves. So, but when it continuously produces lower leaves, which is already dried, we should complete remove. Usually, farmers they remove and burn it, or throw it. So it will lead to many environmental problems. So instead of going for simply burning this trash, we can compost within the field using some certain microbes and some byproducts from certain industries. And the second photo you can see after harvest of sugarcane, the lot of this trash leaves are left. Here also, farmers they simply burn it for cleaning the field and plowing the next crop. But instead of burning, we can spray some microbial consortia we have developed. When we spray it, it completely decomposes the sugarcane trash within month, so that soil will be enriched with high nutrient, and it will reduce the external inputs, and also it will improve the microbial diversity and keeping the soil very healthy and lively. Also, it will decrease the bulk density of soil, because if we the biodiversity increases, the crop productivity will be declined. So the grasses will, because of this high organic matter, it will increase the bulk density of soil, which will can hold water. And second is a kayak pith compost in southern Kerala, Karnataka, and western part of Tamil Nadu. Disposal of this kayak pith is was a problems because after from ask they make kayak. Once they make the kayak, the leftover product is called kayak pith. They simply dump in roadside. Because it's a fine material, it will carry it in the air. But at the same time, because of high lignin content, very difficult to decompose this kayak pith. But we have the development technology. We can use 1% urea and pleurotus fungus. We can compose the same kayak pith within 40 days. Otherwise, it will take 2 years to decompose, and it will be a big environmental problems. So within 40 days, we can compost with it, and we can reuse it as a fertilizer to the crops. Because the one advantage for kayak pith is this kayak pith can absorb water 5 times of weight. If you apply this kayak pith compost 1 ton, it will absorb rainwater. Once the rain comes, it will absorb 5 tons of rainwater and keep it in the field, so that agricultural productivity will be increased and soil health will be increased. At the same time, there's safe disposal of this agriculture waste we can achieve. And nowadays, many techniques have come up where we can make this kayak pith as kayak bales and kayak blocks, compressed kayak blocks, and it can be exported. Once they exported, the receiving country, they can fertilize or use it as a growing medium for any pot culture. And it has become big business in the western part of Tamil Nadu. A lot of incubators are sponsored by many banks, and they're exporting this waste. And in particular about circular economy in sugarcane, because I'm right now I'm working in sugarcane, and how the circular economy practices can help the sugarcane-based agro industry. Let us see the India sugarcane is being grown in 5 million hectares. In cane production is 300 million tons. Soy production is 30 million tons. This 300 million tons leaves at least 30 million tons of sugarcane bagasse. Once sugarcane bagasse is nothing but when we use this sugarcane in sugar industry, the leftover fibrous materials bagasse, every season 30 tons of bagasse is wasted and very difficult to dispose. And ethanol production in our country is entirely depends on sugarcane only, because we are making we are producing 3,650 million liters of ethanol every year, which contributes 73% of bioethanol produced from sugarcane. By maize and rice contributes 27%, but 73% of ethanol production is coming from sugarcane. So number of mills operated in India is 720. So all these mills are producing a lot of agri-industry based waste like bagasse, press mud, molasses. All this can be recycled and value added product we can convert. As I told, first circular economy within the field and with and between the field and the agro-industry. First, within the field, how we can make circular economy working. This, instead of single crops, we can go for combining many crops, many agri-based enterprises like cattle is one agri-based enterprises, and stall-fed goat, and this sugarcane with intercrops, and fisheries culture, mushroom unit, all this we can combine so that all the resources flow within the system, and completely we can avoid the resources requirement from outside, and increase the sustain the soil health, sustain the income generation, and sustain the environment. And see, when we combined many agri enterprises, not growing sugarcane is one enterprise. If we compare it with southern, suppose we are having 1 hectare field, 0.9 hectare field we can grow sugarcane with any legume crops like black gram, and another 0.1 hectares we can distribute to many agri-based enterprises like fodder and goatry, stall-fed goatry, and dairy, having 3 or 4 dairy cattle, and vermic most unit, and poultry and fish. Then it will all resources it flow within the, it's a closed loop systems. Nothing will go out of waste, and nothing is brought in from outside. It's a closed loop system. For example, from sugarcane, it supplies fodder, because sugarcane tops is a good fodder. Sugarcane tops can be fed to the goat or dairy. In turn, dairy will give farming manure to sugarcane, and the goat also give manure to sugarcane. And from fodder, it will supply fodder to fodder unit will supply fodder to dairy and goat unit. And sugarcane also not only gives fodder, the chaff I told in the dried leaves, it will be sourced for vermicomposting. This sugarcane tasks can be composted using earthworms called vermicompost. Also, there is right side you can see we are having one mushroom unit also. For mushroom unit, we need medium this compost. The compost made from sugarcane can be used for growing mushroom. So this waste for agri industry, we can make this compost. We can produce a lot of mushroom. Once the mushroom is harvested, the compost can be recomposted again, because it will have more chemicals. We can recompose again. We can use it for agriculture as a fertilizer. So it is entirely a closed circle, closed loop system. Even within mushroom, showing the closed system. So it is entirely a sustainable production system. The second part is how agriculture, the circular economy works between agriculture and agro-based industry. As you know that we have a lot of byproducts waste generated in agri-based, the sugarcane-based industries. First one is bagasse. The trash is the first sugarcane trash that we are utilizing in the field itself for composting. Second is when we go take this can to sugar mill, the first it will be juice will be extracted. The leftover material is called bagasse. Earlier, all the soil industry, they use this bagasse to make for cogeneration, for generating electricity. But nowadays the bagasse used for making electrical electricity is come down, because it's high cost. It has to be burned and the steam has to be generated, and from the steam electricity should be generated. But lot of alternate options like non-conventional source of energy like windmill and solar is available low cost. So this bagasse can be diverted into for other agri-based products. And second one is molasses. When the juice is crystallized for sucrose, that is sugar, the leftover liquid material is called molasses. Having rich value for many byproducts can be generated from this molasses. When we filtered it, it's called pressed. It's a good source of fats and nutrient, but the problem is we cannot use it in the feed, because it contains a lot of wax, so that we cannot use it for soil amendments used in agriculture. So it has to be treated before using it in agriculture. And fourth is from the molasses we distilled ethanol or spirit. The lot of water spent water as a spent gas will be generated. For every 1 liter of spirit, 13 liter of water is wasted. So this waste, this water is containing a lot of nutrient, but yeah, the COD and BOD value is very high, so that we cannot make directly for any use, unless it is treated. So coming to how we can utilize this sugarcane based agro-industries waste for our circular economy. So first is use of bagasse. Since it is not used for cogeneration of power in the factory, we can divert into many products. First is we can make a briquette made from a carbonized package with molasses and combined with molasses and the clay. It has high energy value. Every gram it gives 4,000 calories. So it have very good energy value. We can make it bagasse based briquettes. And second is like sugarcane leaf, we can make compost and grow mushroom. From bagasse also we can make compost for growing aster mushroom. So this aster mushroom grown from sugarcane, we found that it has 25% higher protein compared to the mushroom grown from mushroom or other agri-based waste. And third one is most of this bagasse is going for print papers. This bagasse, sugarcane bagasse is having 37% of hemicellulose and 32% of cellulose and 20% of lignin. So it is good for making paper. It's ideal for the production of high quality printing and writing paper. The bagasse fibers give paper smooth surface, high strength, good ink absorption, and also it's environmental friendly because this bagasse already contains cellulose. The energy intensive process of wood pulping is no longer necessary. In addition, less bleaching is required as bagasse is naturally lighter than any wood fiber. So the paper produced from bagasse is more environment friendly compared to any wood-based papers, pulp. And also it can be used for making particle board. In apparel industry, bagasse is utilized for production of textile rayon fibers such as viscose, model, and lyocells. And we are having in your museums, we have a lot of materials using this sugarcane bagasse. It appears like silk. There is a premium fabrics we can make it from the bagasses. So considering this importance of bagasse waste, nowadays we are producing a lot of varieties, developing a lot of varieties which have not only good juice quality, it gives good fiber content also, like SBI EC 14006, it's called energy skin. It gives a lot of fiber. So in soy industry, it gives 20% extra bagasse when we go for soy production. And we have licensed some of the industry for not only for pepper industries, it will get for fuel in the industry also. We have licensed. It will be more useful for biofuel, electricity, paper mill, and disposable industries. And lignin is the one byproduct coming from bagasse. Lignin is used in protection of resins, additives, paints, leather, tanning surfaces, plastics, burners, and aromatic chemicals and solvents. Many pharmaceutical and high-value aromatic substances also can be synthesized from lignin, and we have developed a technology to extract lignin from fiber. But thing is, still it is costly compared to other lignin-based product. So here engineer's role is more important. How we can make it cost effective so that more products can be generated from the lignin from bagases. Because personally, lignin is mainly produced from wood or forest resources because it is very cheap. Lignin fractionator from sugarcane bagasse offers the eco-friendly option, but costly, and it needs some technology refinement. And another product we can make it from bagasse operator paper plates. Now growing concern about eco-friendly and plastic waste. Now, the bagasse is more and more diverted into the plates and cup making because it is entirely very safe for humans also and for environment also very safe. Because simply we can fraction this bagasse and make it a liquid form and using high pressure and temperature we can make it molded into any shape. If needed, we can put some starch and make it a very good paper plates. And once we consume it, consume the food, it need not be thrown out. It can be within the any cattle. So can be this even paper plate also it's not better. Again, it can be it can be recycled for cattle food. Always, all other paper plates based on any chemicals will be wasted. This can be entirely utilized. No wastage. Okay. It's a code generation. As I told, nowadays the bagasse to electricity is not common because of high cost. So it is being diverted to other agri-based product. And many value-added product can be made from this juice also, like instead of sucrose or sugar, we can make into spray dried powder so that entire juice quality is maintained here. And also this freeze dried sugar in sugar industry, this entire juices will be converted into sucrose. But here the sucrose is extracted from sugarcane juice in crystallized form. Here, the entire juice is converted into fried and dried. So all good quality, the quality of the dried product is better than sucrose or sugar, white sugar, whatever we are getting from market. Because all the nutrition quality of juice is maintained here. And the excess juice can be very added to sugarcane jam. We know that many the cane jam available in market is 50% pulp, which is having natural factings, and 50% only white sugar, sucrose, white sugar only. But here, the entire we are not adding any sugar. The entire juice is converted into cane jam by adding some natural facting. So it this glycemic index is very low compared to any jam available in the market. The texture is also good. We can infuse with many flavors. Now this jam is available in the Amazon market also, cane jam. And many value-added products with juice, we can make it like because sugarcane we cannot keep it more than 2 hours. It will quality will deteriorate and turn black. But using certain acceptable chemicals, we can make it into popsicles and fruit cubes. Frozen juice blacks, we can make it. And another use of this bagasse waste, we can make it as a fortified food items. Because it's a very good fiber. Sugarcane fiber is very good for human. We can make this a fine fiber out of this bagasse. We can this processed bagasse powder we can we can blend into any cookies, cake, rusk, and bread 5 to 10%, so that it will become a healthy food. And the second leaves leftover can be also converted into a very fodder for the cattle. We can preserve it for a month together by silage. To increase the shelf life, it is inside with the addition of 1 to 5% urea, ammonium sulfate, and molasses in polybags in concrete slabs under anaerobic conditions. It can be stored for 2 years. Otherwise, it will spoil within 2 months. And it's a HPP, high pressure processing cold pasteurization method. Without adding any chemical, we can preserve it, preserve the juice for more than a year using this technology. This is also becoming popular. And another byproduct in sugar industry is molasses. After crystallizing sucrose from sugar from juice, the waste liquid is called molasses. This waste process have many values. It can be converted to many value-added products, mainly used for industrial production of various substances by fermentation, used for sweetening and flavoring foods, used as animal feed and additives. And in alcohol industries, ethanol can be produced by simply fermentation with yeast, no pre-treatment and higher is required compared to starch-based ethanol production, where we have to go for pre-treatment or hydrolysis process. This process can be completely avoided here. Directly, we can go for fermentation with yeast, and it can be distilled as split or 96% split or 100% ethanol. As I told that now 3,000, almost 4,000 million liters of ethanol is produced. It was sufficient, not sufficient, because our ethanol blending in the government of India said 20%. So far, we achieved 50% blending of petrol with ethanol. Still has scope for increasing to 20%. In some other countries, more than 40% also there blending. But we don't know that much of biomass. So in future, if we increase the area or develop the variety which will produce not only sugar, produce more bagasse, maybe it can be sufficient ethanol can be produced. And other produce monosodium glutamate can be produced by aerobic fermentation of molasses by bacteria Mycococcus. Every 4.5 kg of molasses, 1 kg this monosodium glutamate can be produced. So no produce is wasted here. And other use of molasses are many organic acids also we can produce, like molasses fermented by lactobacillus, lactic acid, and by Astrobacter acetic acid, like diacetylic acid. Any acid can be produced from this molasses. And it's a good feed material for yeast, and yeast can be produced for baking industries. And a lot of antibiotics and other pharmaceutical products also can be produced from this molasses, like antibiotics like tartaric acids, vitamins like formic acid, dextran like malic acid, xanthan gum, lysine, azelaic acid. Everything can be produced from sugarcane based byproducts. Hello.
So please proceed, sir.
Closing. Coming,
You're
after when we filter molasses, the leftover material this can be utilized many ways. One application is waste can be the wax can be extracted from the press mud, and this press mud can be utilized for this biofuel like methane, and it can be after treating, it can be used for composting, compost preparation. Biogas from press mud and biocompost from press mud can be made, and so can spent parts also can be used for effluent can be used for making biogas. And for the final slide, we have certain varieties of certain from this rind, many antioxidant and many tablets for glucose can be also prepared. And a significant hyperglycemic are observed from red plus to saccharum robustinis of varieties they have, and it will inhibit all aminase so that it can be used as a potential source for potential tablet for soil. This circular economy is a solution to waste reduction and sustaining environment and productive income. The challenge of processing from linear to circular economy while is still ongoing and requires the development and application of new knowledge and deep innovative technical also required. So that the cooperation of engineers from environment engineers, microbiologists, biochemists, we can make agricultural waste into more useful product. Thank you very much.
Thank you, sir. Thank you for your valuable inputs and insights in organic farming and sugarcane business, how we can utilize that. And Sudarshan sir, are you there, right? Sir, we got some questions for you.
Yes, madam. Yeah.
Yes, sir. So we got a few questions from the audience that what are the biggest challenge industry faced in implementing material passport at scale?
The biggest challenge in implementing this material passport is the patronage towards that particular concept is lagging. As I already mentioned, based on our study, the awareness level is very much lagging, and also it needs to be supported by the policy framework, and the different stakeholders must come forward to support such kind of initiative. Technology is there, concept is there, and it is fetching good outcome in many places. Why not? It can be take it forward. That is the only thing.
Okay, sir. One more question for you. How do we ensure the accuracy and reliability of data in material passport across different supply chains?
Yeah, nowadays there are a lot of concepts like life cycle assessment and other things are existing, and also many countries they are insisting to go for life cycle assessment before the product is coming to the market. So such kind of effort, which and also IGBC, that Green Building Council, they are also giving eco certificate product. They are giving eco certification, and such kind of things needs to be followed before the product is incorporated in the material passport. Once that is done, automatically it will be recognized, and also the validity and the quality of the product can be assured. So now even the new manufactured product also, they are not having such kind of certification, which is not mandatory. It is optional. People who want to get into that such kind of certification, they are going for it. But in some countries, it is mandatory. So such kind of initiative needs to be. See, for example, Dr. Kannan has made many products. There are many circular economy initiatives, and many products have been produced, and also it is in the market. But the government must support such kind of initiative to go for eco certification and other things, which will help to boost the product, which will help to boost the circular economy. So that is lagging.
Sir, a last question for you, sir. Sir, what role do digital technologies like blockchain, IoT, AI play in material passport system?
Yeah, it will play a very significant and vital role, because what I told is only a simple concept and logic. So that can be integrated with many things. Even we can integrate digital twin, we can integrate artificial intelligence, which will help to further make the process much simpler and much easily accessible to any stakeholder. Common man can access it, and he can, like how we are doing the Amazon, Flipkart and other things. In the same way, it can be accessed and it can be processed. So it is very well, it will fit and it will suit to that material passport. But again, it is a challenge.
Thank you, sir. Thank you for all your inputs. And
Because
for
the major issue is we need good amount of quantity of material. If the quantity of material we are unable to get means it will fail. That is one of the major issue even in the case of why the CNT waste is not converted into useful product, because in many of the towns the generation of the CNT waste and in many cases it is not properly recorded and documented. So somewhere they are demolishing and somewhere they are finding a place and dumping it. Not even it is reaching the landfill. Low-lying areas, they are dumping it beneath the sea or under the river banks. So they are doing all these things. So when that kind of things are happening, you won't get the raw material. So if you are not getting the raw material, how you will keep the material passport active? So if that is active, then only you will get good patronage. That is one of the big challenge. Yeah.
yes, sir. Thank you, sir. Thank you for your informations. And for Dr. Kannan, sir, you have few questions. What are the most common misconceptions people have about organic farming?
Yeah. Organic farming, we cannot follow blindly for all crops. Niche area only we can make it, but we can always go for integrated farming, because when we go for only organic farming, of course it's good for environment friendly, but it will not sustain the yield. It requires at least 10 years, then only it is sustained. So entire our food security depends on fertilizer. So always we can reduce the external inputs like chemical fertilizer. We can integrate with organic farming so that we can sustain in long. It will be sustained in the long run.
Okay, sir.
At the same time, organic farming can be at least for niche areas like some spices, wherever export possibilities like basmati rice, we can make.
Okay. So next question is, any innovative financing or support program available for farmers for proceeding with the organic farming, sir?
Yes, under National Organic Farming Mission, they are supporting 50,000 rupees per hectare of land. They support they get good. And the under Tamil Nadu government, green money crops seeds they are supporting free of cost. You can use the seed as an intercrop or in between two crops so that we can increase the productivity.
Okay, sir. Sir, and how about the awareness about the bagasse usage, sir, among the public?
Awareness of policy?
Bagasse usage
Oh.
among the public. Reusing of bagasse into any other product which you develop.
Yeah, but now many small scale industries again already they're doing, and we are not we have the technologies and we are not doing, but using the technology many small scale industries they're using, and nowadays most of the if you go to ISCT train, the material supply, the plates supplies by them are the bagasse based. Not only that, even the tissue paper, some of the color is brown. That's good for not bleached completely. Even in Coimbatore, go for Annapurna hotel, you can see the brown color tissue paper using so can bagasse goodly. So not material is not sufficient bagasse is not available. So nobody knows that. But other consumers, without knowing that, they are using the bagasse based plate. They are consuming this.
Okay, sir. Thank you, sir. Thank you for answering all the clarifications which is requested by the participants. And now, as we come to the conclusion of this insightful webinar, I take this opportunity to express my heartfelt gratitude to all our esteemed speakers, participants, and organizers for making this event a grand success. To formally deliver the vote of thanks, I now invite Dr. G. Madan Mohan, sir, Honorary Secretary, the Institution of Engineers India, Coimbatore Local Center, to propose vote of thanks.
Thank you, madam. Good afternoon, one and all present here. It gives me immense pleasure in proposing the formal vote of thanks in this technical webinar on circular economy, engineering solutions for waste reduction and resource recovery. This is conducted under the aegis of Chemical Engineering Division, organized by Coimbatore Local Center in association with Department of Chemical Engineering, KPR Institute of Engineering and Technology, Coimbatore. Foremost of all, I extend my sincere gratitude to the President of IEI, Chairman, Chemical Engineering Division Board, Director Technical, and Engineer Ayan Deb Sir, Executive Technical, for their unwavering support for all our activities. On behalf of IEA Coimbatore Local Center, I extend my heartfelt gratitude to today's esteemed guest speakers, Dr. J.S. Shudarsan, Head, School of Energy and Environment, NICMAR University, Pune. Thank you, sir. Dr. S.T. Ramesh, Professor, Department of Civil Engineering, National Institute of Technology, Trichy. Thank you, sir. Dr. K. Kannan, Principal Scientist and Head, Crop Production Division, ICAR, Sugarcane Breeding Institute, Coimbatore. Thank you, sir, for accepting our invitation in addressing this particular technical webinar program. I sincerely thank the principal, the management of KPR Institute of Engineering and Technology, Coimbatore, for continuously interacting with our IEI Coimbatore Local Center and for your dedicated support in arranging various technical activities. I thank our beloved chairman, Dr. J. Krishnamurthy, Coimbatore Local Center, for his welcome address and guiding all our center's activities. I thank Lieutenant Dr. A.K. Priya Madam, our committee member, Professor of Department of Chemical Engineering, KPR Institute of Engineering and Technology, for her efforts in organizing this program and moderating this program as well. I thank the participants of this webinar, IEA Council members, committee members, IEA corporate members, industrial members, faculty, and students from KPR and other institutions for their active participations. I wish the participants a fruitful knowledge sharing day today. On behalf of Institution of Engineers India Coimbatore Local Center, I once again thank you one and all here. Thank you, sirs.
Thank you, sir. We formally close this technical webinar. Thank you.
Thank you. Thank you all.
Thank you.
Thank you,
Thank you,
sir.
sir. Thank you very much.
With the
Yeah.
permission of the chairman, sir, I will end the webinar.
Thank you,
Okay,
Ayan.
sir.
Thanks for the.
Thank you all.
Thank you, sir.
Yeah.
Thank you.
Thank you.
Thank you, sir. Bye.